So after 87 iteration, I have finally stopped the calculation, and now we will try to generate the data so that it matches this curve here, right? If we look at the paper again, they obtain this data by a special point in the pipe. They did not get the pipe for the whole direction or the whole pipe. They did not solve the cases. They just solve the cases for this as particular space. I will see you uh, this line. They have solved the cases for this y line. So I ha also have to make this line and solve the pipe for this line. So to do that, let's go on to our results section and go create, and we will create a line like this line. So go to the create and line, and change this ratio, this value to 0.010, and change this to 0.035. I have actually calculated this value. This value is also written in here, 0. Uh, 0.010 and 0.035. All right, and so create. And the line is created. Now we want to see this line. So go to these contours, choose new, and save and display. Go to the mesh. It will show this. Choose line 5 and choose the band and the wall to save and display. You can see the line actually. Like that. If I zoom it a bit, you can see that this line has perfectly touched this point and this point. The red green color, you see that it has already done the pressure study, so I don't need that. Change it to velocity. So we can see that a very high level of velocity is going on this up direction, and the lower direction has a very low velocity. This actually symbolizes this velocity. You see a very there's a vorticity down here, and a lower velocity is in this direction and the high velocity on the upper direction. So our line as well shows this. Anyhow, uh, our main target is to match the data points, so we were going to do that. So save and display. um, let's compute the velocity magnitude to x velocity. Why are we choosing x velocity? Because our this direction, this shorter pipe direction, is on x direction in our case, so that's why we're choosing the x direction velocity. So x velocity and velocity, let's plot a graph from this, then it will be more easier to understand. Cross this and create an xy plot. Create new and change this direction to 0 and this to 1, and show for the line file, the line 5, and change it to velocity and change it to x velocity, and save and plot, and you can see this graph. Very fine, our graph is really resembling this graph. Let me show you our graph in Fluent. If I compare them side by side, okay, it's very congested. Anyhow, you can see this graph really matches this graph here. It's fade out, but we will also do the validation study, so I have to import this data. So go to write to file, and it will import and give it a name. I will save it here and give it velocity profile and okay. And now our next thing to do is to compare this data and our data here. We will plot the graph for this data and this Kim et al. Data in Excel. So now take a screenshot of this and we will collect the data from this picture. Save it in Paint, go to Windows and search for Paint. Use the Paint, open it and Control paste. Enlarge a bit and save it. Save as PNG picture and save it in your recognized file and change it to name for change your desirable name because you have to remember that you have to remember this picture Kim et al. I am saying the Kim data and save and now we have to go to a site that can change that can generate data point from those pictures. Very familiarizing data point that software that can do that is web.digitizer. So go to that. Mm, let's choose web digitizer. Go here and launch version 5. I actually have to sign in. Um, I do not have an account in this, so I have to make an account. So let's make it. Skip these processes if you want. Okay. I have to verify this. Skip this part if you want. Okay, it's a very long process. I am creating an account in this software, in this website actually. I am going to verify and copy this code. Copy, go to here, paste this code and verify. And finally you can use, now choose file, choose the file from the image section. We just click it from the paint. The paint is here and open it. First you have to fix the XY axis value. So go to calibrate and carefully choose the least X value and the highest X value and change the values. In this case, the least X value is minus 0.5. So minus 0.2, minus 0.3, minus 0.4, minus 0.5. So change this data to minus 0.5 and change this data to is 0 plus 0.5 actually. So enter, and now go for the y. Go for y. Carefully select this point and select this point. Uh, and change these values to 0 to 1.2. 0 and change this value to 0.2 and calibrate. Now our next work is to get these data points from this point. The square shapes are the KEM data. So I will take that one by one. It will be long. Just keep your patience and select all the points. This data. It may not be very accurate. Fast forward this if you want. I'm doing it very carefully to take some time to choose all these points. Carefully select all of this point, and the last one would be here. And go to view data and change this to a space and format, and press copy to clipboard and open Excel. I'm opening Excel. Create a blank one and paste all the data here. And now our problem is this: all of this data is selected uh, in one single cell. So I have to change this data to a column. So go to data section and text to column, and go to next and specify this with a space and next and finish. All right, this is the KEM data. So this is the KEM data. So now we will be opening the data for that we have gotten from the Fluent. So go to file, mm, and let's say open this PC. Let's go to the degree band 5, degree band 5. I don't see it. Change the file to all files, or otherwise you will not see the data. It's a velocity profile from the Fluent, and open and choose yes and go for next and next and finish. Okay, so I have to next what I have to do is to copy all of the data. So copy all of this. Before copying this whole data, I have to uh, make this data ready for to compare with this data. As you can see, the R by R ratio is from 0 0.0, 0 minus 0.5 to plus 0.5. So let's change our velocity profile to according to that. This line here is for the velocity. I'm sorry, this line here is for the velocity, and this line here is for the position. So I have to change this position. Mm, let's say, my bad. this is actually the velocity, this column. So change, make another row, press equal, and choose this and divide it by 0.01, and it will give you velocity like this, and copy to the end of the part. It will get a proper velocity field. So you can see the values is not larger than 1.2,